Welcome back to Tech Talks Education. We are still continuing with the stoichiometric calculations, and in this session we are going to look at some calculations whereby we have the calculation of quantities of reactants only. We are not going to jump to the product side. For example, let's look at this number here. Ammonia reacts with lead to oxide according to the following equation. So we have ammonia reacting with lead to oxide. Ammonia is Na3, ammonia gas. It is reacting with the lead to oxide, and it is producing lead metal, and it is producing water as well as nitrogen gas. So let us very fast balance this equation. 2 nitrogen atoms ammonia multiplied by 2, 6 hydrogen atoms on the reactant side, on the product side, multiply water by 3, 3 oxygen atoms multiply lead to oxide by 3, 3 lead atoms multiply lead metal by 3. Now, calculate the volume of ammonia at STP which reacts completely with, so let us look at the mass of 1 mole of lead to oxide in this case. So lead which reacts completely with 55.75 grams of lead to oxide. Given that lead is 207, oxygen is 16, and then 1 mole of the gas at STP is equal to 22,400 cubic centimeters. So we have everything that we need for this calculation. Now, identification of the chemical species. We have ammonia. We are going to use, and we shall deal with its volume at STP. That's why you can see the molecular's volume has been brought back, because we are dealing with a gas. The gas is not in excess. They want us to get the definite volume of ammonia that reacts at STP completely with the 55.76 grams of lead to oxide. So we are also going to consider lead to oxide in our reaction. Remember, ammonia is a reactant, and then lead to oxide is also a reactant. So this reactant reacts with, we are not going to say is produced by or produces, but they react with each other. So let us see. We are having ammonia, and the 2 moles of ammonia we shall convert to volume at STP using the molar gas volume at of ammonia at STP given. And then for lead to oxide, we are going to deal with the mass of lead to oxide. So let us firstly get the molar mass of lead to oxide. Whenever you are dealing with the mass of a substance, first get the molar mass of that substance. And you will multiply the number of moles of that substance by the value of the molar mass that you have got. So this one is equal to 207 plus 16. And this one gives us 207 plus 16, giving us 223 grams. So with ammonia, we are not going to deal with its mass, we are going to deal with its volume at STP. So let us go straight to the calculation. So from this, in this case, we are going to make lead 2 nitrate be on our left hand side. And there are 3 mole, we have 3 moles of lead 2 oxide rather. So we shall have 3 times the molar mass of lead 2 oxide, which is 223 grams of lead 2 oxide, reacts with, because the ammonia is also a reactant, so it reacts with 2 moles of ammonia, that is 2 times 22,400, and the unit is cubic centimeters. This molar gas volume of ammonia, STP of ammonia. So what of the 55.75 grams of lead 2 oxide? It reacts with, then we cross multiply 2 by 22,400 by 55.75, and we divide by 3, we divide by 223 cubic centimeters of ammonia. And what do we get in this case? Let's try to see. So 2 by 22,400 by 55.75, and then we divide by 3 and we divide by 223. So our answer is, let us try to see this one here well. 2 times 22,400 times 55.75 divided by 3 divided by 223. So I have 3,733.333, and the unit remains cubic centimeters, which is approximately, if we are to round up, which is approximately 3,733.33, rounded to 2 decimal places. But please, we start with the correct answer, and that is our answer in this case. So we have calculated the volume of the reactant that reacted with a certain mass of the reactant. Now let us now calculate the mass of a reactant that reacted with a certain volume of also a reactant. So let us look at this example here. So let us see this example here. The example says copper 2 nitrate. Let me use lead 2 nitrate. Lead 2 nitrate reacts with hydrogen chloride according to the following equation. So we have lead to nitrate solution. It reacts with hydrogen chloride gas, and the products are insoluble lead to chloride, and then we also have nitric acid formed. This is a precipitation reaction because we are leading to, or the reaction is leading to the formation of precipitates of an insoluble salt lead to chloride. In this case, so let us calculate the mass of lead to nitrate that reacts completely with, let me try to see something here for us. Let's say with 500 cubic centimeters of hydrogen chloride at room temperature. Given that lead has a relative atomic mass of 207, nitrogen has a relative atomic mass of 14, oxygen with 16, and then 1 mole of a gas at room temperature is equal to 24,000 cubic centimeters. So let us see, what are we using? Lead to nitrate, and we are using with it, we are also using hydrogen chloride. For lead to nitrate, we are dealing with the mass, so we convert it to mass. So we shall say the molar mass of lead to nitrate is equal to 207 plus 14 times 2 plus 16, that's now oxygen, 16 times 3 times 2, and this one gives us 331 grams. So let us now calculate the mass of lead to nitrate. What do? Lead to nitrate goes to our right hand side, and then hydrogen chloride gas, whose volume is given, will be on our left hand side, so that we cross multiply very easily. So we are starting with what we see from here. 1 mole of hydrogen chloride reacts with 1 mole of lead to nitrate. So the molar gas volume of hydrogen chloride is 24,000 cubic centimeters at room temperature. So we shall say 24,000 cubic centimeters, that's 1 mole of hydrogen chloride reacts with 331 grams. Oh, let us not forget to firstly balance this equation. Multiply hydrogen chloride by 2 and then nitric acid also by 2. So since there are 2 moles of hydrogen chloride, we need to multiply also by 2. That is 2 moles of hydrogen chloride. So it is 2 times the molar gas volume. So it reacts with the 331 grams of lead to nitrate. And then what of the 500 cubic centimeters is here? The 500 cubic centimeters of hydrogen chloride. Please mark you this, that don't leave out the number of moles after balancing the equation, or after you have been given a balanced equation. Don't leave out the number of moles in this case. So this one here reacts with, so we cross multiply 331 times 500 out of 2 out of 24,000 grams of lead to nitrate. So we are not changing the unit on each side of the equation. The unit remains the same. You can see here it is cubic centimeters, also here it is cubic centimeters on the left hand side. On the product side we have grams and grams. So let's get the answer here. So the answer is 331 times 500, and we divide by 2 and divide again by 24,000. So this one has given us 3.447916667 grams. Don't get tired of writing the whole value in this case, because if you round off without writing it, that means that you are writing an approximate value. So first write the whole value that appears on the screen of your calculator, and then you can round off to some number of decimal places, and in this case I want to round off to 2 decimal places. It will be 3.45 grams, and that is how we can calculate the mass of a reactant given the volume of a reactant. We had firstly seen how to get the volume of a reactant given the mass of a reactant. So this is Tech Talks Education. Thank you for watching.